Okay, so volume of a prism, we've actually done some of these items before. It's just like finding the volume of any rectangular prism. So we're going to use that skill, finding the volume of a rectangular prism or a cube, and we're going to apply that skill to other shapes. Okay, other prisms, again, are a single shape repeated over and over and over again. You can think of a cylinder, that's a circle that's repeated over and over and over again. You can think of one of the triangle shape that we created in class as a prism. Okay, this is a triangular prism here. It's a triangle that's repeated over and over and over again. It's not a rectangle that's repeated over and over and over again. Okay, this rectangle is as it goes up, as it stacks on top of each other. If this was laid on its side, like if this was laid this way, the rectangular piece on the bottom is not repeated. That rectangle would change shapes as it got closer to the end and eventually disappear. So when we're talking about prisms, we're talking about a base, one shape that's the same on one end and on the other. Okay, so here are your notes. Again, you need to have this done before class. If you don't have this done before class, you're really far behind really quickly. So 2.2, volume of a prism, March 10th, it should be page 46. As far as my count is concerned, it's page 46. And you don't have to write prism again. You've already written it once already, maybe twice. But I put it in here because I want you to see that what a prism is. Okay, just a very quick reminder, it's a 3D shape with a base. Okay, with a base, that is repeated over and over and over again. Okay, so this is really easy. Finding the area of a prism is find the area of the base multiplied by the height. Now this can get confusing if you use the word base as a length or a width. The base in the case of a 3D figure, the base is considered the bottom or the repeated figure. Okay, so let's start off with this rectangular prism. Now this is something we've already done before, so we know how to find the volume, but we're going to use this as a guide to solving the next two problems, which are a triangle and a pentagon. Okay, now when we said one, find the area of the base, so area of the base we are talking about the shape that's repeated over and over and over again. This shape across the bottom, this square that is at an angle, so it looks like a parallelogram. This shape is just repeated up, 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 all the way. Think about a stack of paper that's stacked really, really high, okay? And a whole bunch of stacks of paper will make this three-dimensional shape, okay? So let's just find the area of the bottom piece first, okay? The area of this bottom piece, that bottom piece, okay, is called our base. This down here is our base. Okay, so this is our base. It's the part that's repeated over and over and over again. Okay, so how do I find the area of that? Well, that's a 5 by 8. So area of base is going to be 5 inches times 8 inches, which will give us 40 inches, 40 inches squared. 40 inches squared. Okay, that's my base. Okay, now the second thing I need to do is multiply it by the height. Second thing is multiply by height. Multiply the base area, okay, base area times height. Okay, well here's my base area. That's this number. Okay, that's my base, 40 times, okay, inches squared, 40 inches squared, times my height. Okay, times height. Times my height, which is this number here, 12. Okay, now I know you've seen this before and you're like, okay, Mr. P, I'm just gonna multiply 5 times 8 times 12. No big deal. Yes, that's true, no big deal. And Yes, that is true, and that works every single time for rectangular prisms, and we just called them 3D shapes, or we called them cubes or whatever. Um, 40 times 12 is 480 inches cubed. Because this is squared, we have another value that makes 3 values of inches. Okay, now that's not quite as easy because I can't just do 8 times 5 times 12. This is actually half of that shape. So if I just did 8 times 5 times 12 like I did before, I would get the wrong answer. It wouldn't work quite right. So again, let's find the area of the base. Okay, the area of the base is going to be 8 times 5. That's this section here. But, okay, or it could be the section down here, this triangle. Okay, it's the same thing. They're both the base. 8 times 5, but then we have to divide it by 2. Okay, we're dividing it by 2 because this is the area of a triangle. Okay, length times width divided by 2. I don't say base times height because that really gets confusing having two values of a base. Okay, so my base down here, this is my base, which is this, is equal to 8 times 5, which is 40, divided by 2 equals 20 inches squared. That's my area of my base. That's step 1. Step 2, I'm going to multiply that, my 20 inches squared. 20 inches squared. I'm going to multiply that by its height, which is 12. So times 12, okay, inches gives me 240 inches cubed. That's how many cubes will fit inside this box, this triangular prism. Now, we didn't learn how to find the area of a hexagon. And that's not part of what we're learning. We're just learning how to find the volume of this prism. So we need to find the volume of this hexagonal prism. So I need to find the area of the base. So find the area of the base. I don't know how the calculation, but it tells me right here. Area of a base is about 166 inches squared. So I'm going to use that data, 166 inches squared. That's my base. Done. I don't have to calculate it. It's given to me. You should learn in high school geometry how to find these items. We're not learning that in 7th grade. It's not part of our curriculum. Okay, so 2, I'm going to find the area of the base, 166 inches squared, times the height, which is 12 inches. Okay, so let me label these so I know what this is. Area of base times height. This is my height. Okay, and that is the same for all of the other ones as well. So 166 times 12, our total area is going to be 1,992 inches cubed. Okay, again, that's a squared value. This should be a 1 value. I labeled that incorrectly. Okay, a 2 value and a 1 value makes me a cubed value when I'm multiplying. Volume is so much easier, so volume's finished. Okay, at the end of these sets of notes, you're going to write a summary. Okay, what is this investigation about? Maybe how can you find the volume of a prism? You should know how to do that. Again, describe what a prism is. Knowing what a prism is really important. Most of the time we just use that word and we haven't defined it. What is volume? Okay, what is the base of a prism? So specifically, what do these first things, this base is? What is this? How would you describe that to somebody if you were to teach them what it is? Okay, questions. Write down questions for clarification. It's like, I didn't understand this. If you're like, I don't know what to write, highlight it, put a question mark. Hopefully that'll remind you what to ask me in class. We will review this in class. We have a lot of work to do, a lot of things to catch up on. If you don't have any questions, write down questions you think others will have. And lastly, you could create your own math question that would be a good question for a test or a quiz. You only have to do one of these. Your summary should include pretty much all these ideas for it to be a complete summary. Okay. these questions here about the air volume of the base, all this stuff is actually in your textbook on page 31. I just picked them out of here. Okay, they give you question B as another value. They're just giving you a written explanation of it. Okay. The other item that we're going to do is we're going to watch a video, and I'll play it on here so you can see it. Is the slicing of 3D figures. I'll bring on some Play-Doh next class so we can see what that looks like. Okay, so this is a video I found online called Slice Master 2000. It's put on by PBS Math Club, and it really helps us distinguish what a 3D shape looks like, and when slicing it, what really happens. Okay, so I'm gonna let this play. I'll also put the link if you want to watch it, not on my video. Okay, so this is Slice Master 2000.
Tired of all that chopping and slicing.
Ah, this cube just won't cut.
Such hard work, and it takes forever. My geometry fruit salad's all lumpy. Now there's a better way to transform those 3D shapes into perfect 2D shapes. The Slice Master 2000. It lets you slice, slice, slice 3D figures into perfectly flat 2D shapes. Great for squared potatoes au gratin.
Delicious.
With just one flick of the easy slice handle, and an entire sphere is sliced into circles. In seconds! No odors, no tears. With Slice Master 2000, transform any 3D shape into a 2D figure with just a flick of the wrist. By 182 1/4. Now! It's like so easy. Pyramids can become squares. Rectangular prisms can become rectangles. Cuboids can become rhomboids. That's a thing? It totally is. Oh, that is so totally cool. Wait, no, not you. No, keep buying. At the heart of the Slice Master 2000 is the patented plane creator. 3-dimensional objects have 3 dimensions: length, width, and height. But when our plane creator intersects a 3D shape, the height gets chopped off. All that's left is a 2-dimensional slice, length and width. It's goodbye height, hello 2D slice. Cutting 3D shapes the old way can be dangerous. But with Slice Master, your hands never touch the plane. Turning spheres into circles has never been so easy, especially if you're blindfolded.
Can I take this off now?
No, but wait, that's not all. Use the angled Jinsu cut adapter, included to create a bouquet of slices from a single 3D object. Drive the Jinsu adapter through the apex of a pyramid, you get a triangle. But cut it horizontally, you can get a square. Cut it vertically, not through the apex, get a trapezoid, all from a single object. Add the deluxe linearizer, and the Slice Master 2000 removes both the height and width, creating mouth-watering one-dimensional segments, 2 points connected by a line, in seconds.
Great for stir fry.
The best part of the Slice Master 2000 is the price. It's totally free, because it already exists in your mind. Have a homework problem where you need to take a 2D slice from a 3D object? Place that 3D shape into your Slice Master and slice it with your mind. Perfect 2D slices every time. Slice Master 2000, the 2D slice that's great for life. Best thing is your hands won't even touch the blade.
Scene 13, take 1 product shot.
Are you saying that wrong?
No.
Okay, so just a reminder, this should be done before class. 2.2, volume of a prism, page 46. The slicing of a 3D figure we'll talk about more in class. We'll have we don't have any notes for that specifically, only because it's so difficult to draw things. I'll give you guys a worksheet, and we're going to glue it into your notebook. But this will end investigation 2. Next week we're doing with circles. So if you had trouble with 3D shapes that give you a specific value, next week with circles we're dealing with pi, and pi has is an irrational number, so that becomes even more difficult. Okay, so we really gotta make sure that we understand what prisms are before we start moving into cylinders and circles. Okay, again, here are your notes. Copy them down. I'll put the link for the Slice Master 2000 and one more video in your homework section.